Hello, welcome everybody. Today we were going to talk about the limits of compositions and operations of functions. What that means is I want to find the limit of a function where the graph is given or the equation is given, but we have a composite setup. So that means that we have a function within a function. So for example, like the limit as x approaches towards 0 of f of x or f of g of x or something, of that sense. Now, if you take a look at this first example over here, this will be an example of what I'm talking about. Limit as x approaches towards 0 of f of x, where f of x is the graph that's given right above. One really big misconception is that people would think, okay, I can go ahead and use the limit property, which says the following. This is the same thing as f of limit as x approaches towards 0 of f of x. And as a result, the limit as x approaches towards 0 looks like it's going to be equal to 2. So one would then say this is equal to f of 2. And so then the answer would then be equal to negative 2. This unfortunately does not work because in order for us to use this definition over here, or in order for us to use this little theorem over here, we need to make sure that f, the outer function, has to be continuous. Okay, so repeating it one more time. In order for us to use this function right here, f, the outer function, has to be continuous in the domain that we are using. Okay, and so if you notice that at x equals to 2, it is not continuous over there, so we can't actually do that, nor is it continuous at 0. So that means that this is going to raise some sort of complication. So the question then is, how do you do a problem like this then without having to use this method? Well, first of all, what we're going to have to do is we're going to have to kind of unlearn this whole thing and go back to our original definition. And that is to say, I need to look at the limit as a two-sided limit from the left and the limit coming from the right. So what I'll do first is I'm going to go ahead and take this guy and rewrite it. So first, I'm going to go ahead and solve for the limit as x approaches towards 0, coming from the left of f of x. Okay, so I want to solve for that piece. Then I'm also going to solve for limit as x approaches towards 0 from the right-hand side of f of x. So taking what I'm trying to solve for and breaking it into two parts, just like as we normally would in order to see if the limit actually exists. If the limit from the left is the same as the limit from the right, then we're pretty much good for. Now, here's the part that will help you see what's going to happen. Instead of having like these inside composite functions, I'm going to go ahead and make a quick substitution. I'm going to go ahead and say let u equal to f of x, where it's basically saying, hey, I'm going to go ahead and replace the inner function with a simple variable. Okay, so I'm going to go ahead and say let u equal to f of x. So just a quick replacement. And what's going to happen now is we're going to take our limit problem and change it so that our variables are in terms of u. So limit as u approaches towards, and this is what we're going to have to do a little bit of digging then. Okay, now for this part over here on the right, this is going to say limit as u approaches towards some number, which we're going to have to find out, of f of u. Okay, so this is a very common tactic in the calculus course. Now, let's go ahead and go to our graph right here so you can see what f looks like. Remember, for our problem, we're looking at x is approaching towards 0 from the left. Now, I'm approaching towards 0 from the left, so that means I'm coming from in this way right here. And as x is getting closer and closer to 0, notice that the function, the y value, is getting closer and closer to 2. But more specifically, it is increasing to 2. So it's kind of like saying going from 1.5 to 1.7 to 1.9 to 2. So what that means is, in my translation, if I let u equal to f of x, then the limit as x approaches towards 0 from the left becomes limit as u approaches towards 2 from the left, because we just said that it's coming from 1.5 to 1.7 to 1.9 to 1.99. Okay. Now, for this part over here on the right, we're going to do exactly the same thing. I'm going to also say let u equal to f of x. So then now we have the limit as u approaches towards, and I need to figure that part out, of f of u. Okay, so for this guy, I'm looking at x is approaching towards 0 from the right-hand side. So going back to my graph, I'm going towards 0 from the right-hand side. So that means that I'm going this way from the right to left. And if you notice that my y value is also approaching towards 2, and it's also doing exactly the same thing. It's going towards 2 from the bottom. So that means you're, again, having 1.5, 1.7, 1.9, 1.99. So in that sense, this now becomes limit as u approaches towards 2, because that's the y value that it's getting closer and closer to. And also with a marker that is indicating from the left, because it is going again from 1.5 to 1.7 to 1.9 and so on and so on and so on. Hey, that's kind of nice because look, if you notice, both of our limits that we're trying to solve for is asking for exactly the same thing. So that means the limit has to exist. All we have to do now is figure out what that limit is. So final step, we're going to go back to my graph f right here. And even though my variable says u, is really just the same thing as x, right? Because that's just the independent variable, just being replaced by another dummy variable. So in the very last part of it, I'm going to look at what happens when u goes to 2 from the left, or if you want, you can say x approaching towards 2 from the left. So on the graph, right, I'm looking at going towards 2, but coming in from the left-hand side. And so graphically, now you can see that it's getting closer and closer to 0. So my answer for this one is going to be equal to 0, just as my answer over here is equal to 0. So since both of the limits are equal to each other, then that means that my final answer is that it's equal to 0. Okay. So let's try it again now with a different example, or just kind of like the same setup, just to make sure that you guys are understanding it. So once again, I have f of x over here. And what I want to do is, I don't know what happened to my equation. Maybe I erased it. Let me go ahead and write it up then. So this time I'm going to say, let's go ahead and try to find the following. Limit as x is approaching towards the square root of 2 of f of x squared. Actually, I think that's what I had in mind. Okay, so let me go ahead and erase that. And let me go ahead and write it in like this. Okay. All right, so once again, what we need to do is create some sort of u substitution to figure out how this is actually going to work. Again, if you're thinking of just directly substituting x equals to root 2 into there, that doesn't work because remember, f is not continuous at x equals 2, so we cannot make a direct substitution. It has to be continuous for the outer function. So with that being said, let's do exactly the same thing. Limit as x approaches towards root 2 from the left of f of x squared. Okay, and then we also want to find the limit as x approaches towards root 2 from the right of f of x squared. Coming from the left, coming from the right, I want to see exactly what happens. So now we're going to make our substitution. Let u equal to x squared. Let u equal to x squared and solve for each one individually. So here on the left, we have limit as u is approaching towards, and we'll figure out what that is in a little bit, of just plain old f of u. Now, in terms of what u is going towards, remember, x is supposed to be going towards root 2 from the left-hand side. So if you're approaching towards root 2 from the left-hand side, let's think about how that works then. So x is approaching towards root 2 from the left-hand side of x squared. Okay, so if I am coming from the left-hand side, then maybe I can plug in something like, say, negative 3. Not negative 3. I can plug in, like, say, x is equal to 1, and then I'm going to get 1 for x squared. Sorry, let me repeat that one more time. If x is equal to 1, then that means that x squared is equal to 1. If x is equal to 1.2 or 1.1, let's make it a little bit simpler, then x squared is equal to 1.21. Right? And then if x is equal to 1.3, then we have x squared is going to be equal to 1.69. And as you get closer and closer, when x becomes root 2, then now you're going to get x squared is equal to 2. So looking at these numbers right here, you can see that you're increasing to 2 for x squared. So my conclusion is that over here, the limit as u is approaching towards 2 because square root of 2 gets squared, it becomes 2. But more importantly, it's coming from the left-hand side because you're increasing the values to 2. So this is coming from 2, going towards 2 from the left-hand side. Now for the other one, same deal. Limit as u is approaching towards question mark of f of u. Again, u being x squared. Now this time I'm coming from the right-hand side, right? So that means that I'm going to go start from like 3 and then 2 and then so on and so on and so on. So in this case, I'm going to go ahead and see what that looks like as a chart. So let's say that let's say that x is equal to 10. So that means that x squared is equal to 100. X is equal to 5. So x squared is equal to 25. X is equal to 2. So then x squared is equal to 4. And then finally, x is equal to root 2. And so x squared is equal to 2. So just like on the left-hand side, the limit is x is approaching towards root 2. We're going to get also limit as u is approaching towards 2 because that's what you're getting numerically. But the difference now is that you're coming from a big number to a small number. So what that means is graphically, you're coming from the right-hand side to the left-hand side. So that means that this is looking at limit as u approaches towards 2 from the left of f of u. Finally, we're going to go ahead and go to the graph and see what happens in each case, right? So here's 2, and then I want to see what happens when it comes from the left-hand side according to this one. So in this case, coming from the left-hand side, my graph, the y value is getting closer and closer to 0. So that's going to be my answer on the left. But coming from the right-hand side, that means I'm coming this way, and you'll notice that the limit over there is equal to -2. And because these two do not match each other, then that means that my final answer is that this does not exist because the limit coming from the left is not the same as the limit coming from the right. Okay. All right, so here is the last example. This is what it's supposed to look like. And, you know, again, if you want to give it a shot before I actually do all of these, you feel free to go ahead and do so. But, you know, if not, then you can just go ahead and watch the video then. So what I want to do is I want to solve for the limit as x approaches towards 0 of g of f of x. And you can see here I have two functions. If I were to do a direct substitution just to see how it goes, let's see, as x goes to 0 for f, that is going to go to 2. So one might think that this is equal to g of 2 then. Here, let me kind of like write it out as if, you know, if I was showing my steps. So according to my property, then this is going to give me g of the limit as x approaches towards 0 of f of x. And so the limit as x approaches towards 0 for f is going to be this guy over here, which is going to be 2. So one might say the answer is g of 2. So then that means according to this over here, my answer is equal to -1. But again, we cannot do that because g is not continuous at 2. So therefore, we cannot actually use this theorem. So all this right here, that's just garbage. Okay. So let's go now and do it the proper way. And so what we're going to do is we're going to go ahead and break it up into two parts, just like we did. So solving for limit as x approaches towards 0 from the left of g of f of x, limit as x approaches towards 0 from the right of g of f of x. And same as before, let u equal to f of x, the inner function over here, just so that you can make it a lot simpler. So it looks like I have it written out, so we can kind of skip a few steps. If we do so, then we have limit as u approaches towards 2 from the left-hand side of g of u. Sorry, this is supposed to say g of u over here. Okay, so let me put that in. And then for the other one, it's also approaching towards u from the left-hand side of g of u then. Okay? So let's just make sure that that's exactly what's happening. Remember, u is equal to f of x, and x is approaching towards 0 from the left then. So here's f of x right here, and u is approaching towards 0 from f of x. So that means you're going towards this way, right? And so you can see that it's basically going towards 2 for the y value, and it's increasing towards 2 because you're coming from the bottom to the top. So you're going from down to up. So that's why this guy over here is u approaching towards 2 from the left-hand side. Whereas for this guy over here on the right-hand side, x approaches towards 0 from the right-hand side of g of f of x. Again, looking at f of x, the inner function, we're coming from the right-hand side, and we're also approaching towards 2. But just like the previous part, we're going to increase towards 2 from the bottom to the top. So that means we're approaching towards 2 from the left-hand side of u then. Okay. So since they both agree on the same thing, that means the limit actually exists. And now we can go ahead and solve for each one. So we go to the g graph and look at what happens when the variable is getting closer to 2 for the independent variable from the left. So it looks like we're going to go towards this way, and it looks like it's going to go to this removable discontinuity. So then that means our answer is then equal to 1 for both of them. So therefore, the limit is equal to 1 then. All right, so hopefully that helps out. Leave a comment if you need